State model of linear system and state diagram. So first we see what is state model of linear system and followed by state diagram. So state model of linear system. The state model of a system consists of the state equation and output equation. So ఒక system state model అంటే it has two equations, state equation and output equation. So x dot t equal to a x of t plus b u of t is a state equation, and y of t is equals to c x of t plus d u of t, so which is called as output equation. So these two equations combinedly called as a state model of a system. The state equation, so x dot of t equal to a x of t plus b u of t is a state equation. The state equation of a system is a function of state variables and inputs. So if you see the state equation, so it is function of state variables. So here x of t is state variables and u of t is input. The output at any time are functions of state variables and inputs, and y of t equal to c x of t plus d u of t is called as output equation. Output is also function of state variables and input. So this is state model of linear system. Now let us see what is state diagram. So if we give a diagram form for these two equations, it is said to be state diagram. So the block diagram in time domain representation of the state model is, so here x dot t equal to a x of t plus b u of t. So relation between x dot t and x of t is, so x dot t is differentiation of x of t. So if you take integration for this, you get x of t. So that is the relation between x dot t and x of t. So integration of x dot t is x of t. Now let us get x dot t. So x dot t equal to a x of t plus b u of t. So here we have u of t, and here we have y of t output, and here there is a, and it is b, here there is c, here there is d. So x dot t is equals to a x of t plus b u of t. So from the equation, state equation, x dot t is equals to a x of t plus b u of t. So x dot t equal to a x of t plus, so at the summing point there are two signals, one is a x of t and one is b u of t. So a x of t plus b u of t is equals to x dot t. So this is state equation. And the second one is output equation. So y of t is equals to c x of t plus d u of t. So y of t, here y of t, so y of t is the sum of two signals. One is c x of t and second one is d u of t. So c x of t is one signal, d u of t is second signal, and sum of that two signals is nothing but y of t. So if we give a diagrammatic form for these two equations, which are called as state equation and output equation, combinedly called as state model of a system, that is state diagram. So this is the state diagram. So if we give a, even we can give signal flow graph for this state diagram. So the signal flow graph in time domain representation of the state model is, so here it is a integration dt x dot t. For the summing point we can take x dot t, and at the summing point we can take x of t, and gain of this feedback loop is a, and the input is u of t, output is y of t, and here the different variables are u of t is input, y of t is output, x of t is variables, and x dot t is the differentiation of variables, and x dot t and x of t relation is, if you take integration for this differentiation of variables, so integration of x dot t is x of t, a is state matrix, and B is input matrix, and C is output matrix, and D is transmission matrix. So x dot t equal to a x of t plus b u of t, y of t equal to c x of t plus d u of t. So here in this video, it is about state model of linear system and state diagram. So state model of linear system is this state equation and output equation combinedly called as state model of a system. If we give a diagrammatic form of for these two equations, it is said to be state diagram. So one is a block diagram and one is a signal flow graph.